video, I will be showing some example of the use of the Fundamental Theorem of Calculus. Remember, the Fundamental Theorem of Calculus says that the integral of a function from a to b, remember that this integral is associated with the area between the function and the x-axis. This definite integral from a to b is equal to the antiderivative evaluated in b, the number that appears here at the top, minus the same antiderivative evaluated in the number that appears at the bottom. So let's use this fundamental theorem of calculus to compute the definite integral of a function. For example, let's see this function. We want to compute the integral from 1 to 3, the x squared plus the natural logarithm of x dx. And obviously, if we use the fundamental theorem of calculus, it will be the antiderivative evaluated in 3 minus the antiderivative evaluated in 1. So let's compute the antiderivative to get the solution. So the integral from 1 to 3 of x squared plus the natural logarithm of x dx will be equal, remember this is a sum, to get the antiderivative I'm going to get the integral of x squared is x to the power 3 over 3, or 1/3 of x to the power 3. So it will be 1/3 of x to the power 3. So we remember we add 1 to the exponent, and the same exponent is going to be written as the denominator. Plus the integral of the natural logarithm of x. In another video, I compute this antiderivative using integration by parts. The integral of the natural logarithm of x, or the antiderivative of the natural logarithm of x, equal x natural logarithm of x minus x plus c. So we can use it here. So I'm going to try here, plus x natural logarithm of x minus x. And obviously any antiderivative have a constant of integration, but you can use the easiest constant of integration, that is 0. Here this f can be whatever antiderivative, and the antiderivative could be that have the constant of integration equal 0. Any other constant will gonna work because they at the end cancel. The constant of integration here minus the constant of integration in the second function, they cancel. You don't need actually in this case to use a constant of integration. And I'm going to evaluate this antiderivative in 1 and 3. To symbolize this, I'm going to write it this way. And the formula say that I need to evaluate it first in 3 and then in 1. So I'm going to substitute x by 3 in this function, and then I'm going to substitute in the same function x by 1. So that will be evaluating the derivative in 3 minus the antiderivative in a. So let's substitute by 3. We get here 1 over 3, 3 to the power 3 in this case. And here we'll have 3 natural logarithm of 3 minus 3. This is in the case that we are substituting x by 3. So here we have 3 natural logarithm of 3 minus 3. Minus the antiderivative evaluated in a. In this case, a is 1. So it will be the same thing, now substituting x by 1. So it will be minus, I will be open bracket, minus 1 over 3, 1 to the power 3, plus 1 natural logarithm of 1 minus 1, and I cross bracket because I noted that this minus is for the whole expression, for the antiderivative in a. So then I just need to simplify. 3 to the power 3 is 27, 27 over 3 is 9. This is just 9 minus 3, this is 6. So we have here 6 plus 3 natural logarithm of 3. Minus, and in this case we have minus, this is 1/3, 1/3 minus 1, so it will be negative 2/3. So we have natural logarithm of 1 minus 2/3, so it will be natural logarithm of 1 minus 2/3. We have that the natural logarithm of 1 is 0, and this is minus 2 over 3. With this minus will be actually plus 2 over 3. So So it will be 6 plus 3 natural logarithm of 3 plus 2 over 3. And this 6 plus 2 over 3, this is 18 over 3 plus 2 over 3 is 20 over 3 plus 3 natural logarithm of 3. And if you want to know what number is this in decimal, you just your calculator. 3 multiplied by the natural logarithm of 3 plus 20 over 3. So I get 9.96. This is the value of this definite integral, that you know that will be always a number, a real number. Okay, this is this example. Let's make another example. The integral from 2 to 5 of 3x squared minus ax plus 2 dx. So what we are going to do is get the integral from 2 to 5, so the definite integral. And we know using the Fundamental Theorem of Calculus that will be the antiderivative evaluated in the second value in 5 minus the antiderivative evaluated in 2. So we need to compute the antiderivative of 3x squared minus 8x plus 2. What we are going to do is get the integral of the first term. It will be x to the power 3 over 3. So remember, a constant multiplied by a function will be the constant 3 multiplied by x to the power 3 over 3. So it will be, so because we have this factor 3, so we have 3. The new exponent will be 3, and this new exponent will be also the denominator of a factor. You can type also x3 divided by 3. So we have here the first term, 3 over 3 x to the power 3. In the second one, we notice that the exponent will be 2. The exponent is now 1. The exponent will be 2, and this 2 will be also the denominator of the factor. So it will be minus a over 2 x to the power 2. And finally, this is like x to the power 0. So it will be 2x to the power 1 divided by 1. So it will be 2x to the power 1 or 2x. And that's it. We know that we don't need to use any constant of integration in this case. So this will be evaluated in 2 and 5. So I'm going to write here. And I know that it will be always evaluated in 5 minus the antiderivative evaluated in 2. Let's simplify this first. This will be s cubed only. This will be a over 2 will be 4x squared plus 2x. It will be s cubed minus 4x squared plus 2x, evaluated from 2 to 5. And then let's substitute x by 5 first. And if we substitute by 5, will be 5 to the power 3 minus 4 times 5 to the power 2 plus 2 times 5. So it will be this minus the same, but now evaluated in 2. It will be 2 to the power 3 minus 4, 2 to the power 2, and 2 times 2. Everything preceded by this minus sign. This is the minus of the formula of the Fundamental Theorem of Calculus. So let's evaluate this. 5 to the power cube is 125. 5 squared is 25. 4 times 25 is 100. 125 minus 100. It will be 25. Plus 10 will be 35. So 35. And the other side we have 8. 2 to the power 3 is 8. 4 times 4, it will be 16. A minus 16, negative a. Negative a plus 4 is negative 4. So it will be minus 4. And this will be 35 plus 4 equals 39. So this is the value of this definite integral. And obviously this will be a number. Anytime that we are computing the definite integral, this will be a real number. Okay, I think with this I have finished my explanation of the use of the Fundamental Theorem of Calculus for computing the definite integral. I hope you have found it useful. Thank you.